This is factoring polynomials completely. When we say factored completely, this is a polynomial written as a product of unfactorable polynomials with integer coefficients. The guidelines for factoring polynomials completely include making sure you factor out the greatest common monomial factor, make sure that you've looked for a difference of two squares or a perfect square trinomial, factoring a trinomial of the form ax squared plus bx plus c into a product of binomial factors, or factoring a polynomial with four terms by grouping. Now we've talked about all of the things in this list except number 4, factoring by grouping. Factoring by grouping means to use the distributive property to factor a polynomial with four terms. So let's take a look at some examples where we would factor by grouping. So here our polynomial has four terms, but I'm going to create two groups where I can factor something common out of those groups. So in this case, I'm going to put together my x cubed and my 3x squared. And I'm going to make a group of my 2x plus 6. Now what I'm going to do is factor something out of each of these groups. From this group, I'm going to factor out the greatest common monomial, which is x squared. That's going to leave me with x plus 3. And over here, I'm going to factor out 2, which is also going to leave me with x plus 3. So both x squared and 2 are being multiplied by x plus 3. So another way to write that is x squared plus 2 times x plus 3. If I want to check this and make sure that it actually gives me this polynomial, I can try the FOIL method here. So x squared times x is going to give us x to the third. X squared times 3 is going to give us 3x squared. 2 times x is going to give us 2x, and 2 times 3 is going to give us 6. So it checks out. Let's try another one. So in this case, I'm going to group my x squared and my x, and I'm going to group my y and my xy. And I mostly picked this because I wanted my y's together. So here I'm going to take an x out of these guys, and I'll be left with x plus 1. Here I'm going to take out a y, and I'll be left with 1 plus x. And x plus 1 and 1 plus x are essentially the same binomial. So I've got x plus y, both of which need to be multiplied by x plus 1. And I can always check it by using my FOIL method. My first x times x is x squared. Then my outside x times 1 is x. My inside y times x is yx. And my last y times 1 is y. So even though it's in a different order here, it's the same polynomial. So let's make sure that these polynomials are factored completely using our rules. So in this case, the first thing I notice is that all of these can be divided by 3x. So I'm going to factor out my greatest common monomial of 3x. That leaves me with x squared plus 2x minus 6. In this case, there isn't anything that multiplies to give us -6 that would add to give us 2. So this is factored completely. This is as low as we can get this one. Here I'm going to start by factoring out my greatest common monomial, which in this case is 7x squared. So I'll be left with x squared minus 4. Now, this guy is actually a special polynomial, which can be rewritten as x squared minus 2 squared. So that can be broken into x plus 2 times x minus 2. Now it is factored completely. Let's try solving an equation by factoring completely. So the first thing that I want to do here is get this equation equal to 0. So I'm going to rewrite it as 2x to the third plus 8x squared minus 10x equals 0. The next thing I'm going to do here is factor out my greatest common monomial. I see all of these terms can be divided by 2 and x. So I'm going to take out a 2x, which will leave me with x squared plus 4x minus 5. Now, this guy can be factored into two binomials. I'm looking for two numbers that multiply to give me negative 5 and have a sum of 4. So it's going to be x plus 5 and x minus 1. So now I can solve for my values of x, because that's what they want me to do. They want me to solve this equation. So x could be 0, because 2 times 0 would make this term 0, and 0 times anything is going to get us 0. Or x could be negative 5, because that would make this second term 0. Or x could be 1, because that would make my third term 0. So there's 3 possibilities for x here, which would make my equation equal to 0. X could be 0, negative 5, or 1. Now the last thing we're going to do is take a look at a real life problem, because even though we might get multiple answers for x, they don't always make sense in a real life problem. So here we have a terrarium in the shape of a rectangular prism, and it has a volume of 4,608 inches cubed. We know its length is more than 10 inches. The dimensions of the terrarium are given in terms of the width, and we are supposed to find the length, width, and height of this terrarium. Well, for a rectangular prism, the base would be the length times width, and I multiply that by the height to get my volume. So in this case, I'm going to do all 3 of these multiplied by each other. So I'm going to do w times 36 minus w times w plus 4. And this is going to be equal to 4,608. So the first thing I'm going to do is try to turn this into one polynomial by doing some foiling. So I'm going to do 36 times w plus 36 times 4 is going to give me 144 minus w squared minus 4w. All right, so now I'm going to multiply in my w here, and I'm going to get 36 w squared plus 144 w minus w to the third minus 4w squared equals 4,608. All right, and from here, what I'm going to do is do a little bit of combining. I've got my w squareds, so that's going to become 32 w squared plus 144 w minus w to the third, and I'm going to subtract this 4,608, so my equation is equal to 0. Now I've got 4 terms in this polynomial, so I'm going to try to factor it by grouping. I just have to decide what groups I'm going to put together here. So I'm going to put the negative w to the third together here with my 32 w squared and my 144 w with my 4,608. Now this guy starts with a negative, so I'm just going to factor out this negative and make it w to the third, minus 32w squared. So that one's going to be a little bit easier to work with. Okay, my greatest common monomial for these guys is going to be to take out a w squared. So it's going to become negative w squared out here, W minus 32. For these guys, I'm going to take out a 144, which is going to make this W minus 32. So my first binomial here is going to be, I'm going to keep this negative out here, W squared, and it's going to be minus 144, because I'm keeping out that negative, and W minus 32. So in this case, this one can be factored a little bit more. It's the W squared minus 12 squared. So this one can actually be written as W plus 12, W minus 12, and I have W minus 32. So possibilities for W include negative 12, 12, and 32. Well, automatically the negative is not going to work. I'm not going to be able to have a negative width. So that one's out. They also told us that the length is more than 10 inches. So let's test this length. 36 minus W gives us our length. So 36 minus 12 would leave us with a length of 24 inches. That would work. 36 minus 32 would leave us a length of 4 inches. So this one would not work. So the width has to be 12. So the length here is 24 inches, the width is 12 inches, and the height is 12 plus 4, so the height is 16 inches.